Okay, today we are going to solve trapping rainwater. So, given n non-negative integer representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. So, basically, we have an array called heights here, and every value in this array represents the height of a wall. And let's just assume all the walls have the same width. So in case it rains, that means we'll start filling these um, gaps from the top, that is vertically. We want to return how much rainwater we can trap or how much area we can cover. So all of these block is of area 1. So 1, 2, 3, 4, 5, and 6. That's why the answer is 6 here. One thing to notice is nothing can get filled here or outside here. Just that we have to consider these as open boundaries, so nothing can be captured there. Everything has to be between the end walls. So if we consider this first example, as you can see we had height of 0, which is this, then height of 1, and since this is an open area, nothing can get filled here because water will flow from the left. Now if we consider this particular area, we have 1, 0 and 2. So initially the height is 1, then 0 and then 2. So if we start filling it from the top, water will get filled till here and then it will start overflowing. So the maximum height we can reach is the height of the lowest of the pair. So the wall on the both side, right? Similarly, if we consider these 0 to 1, 0 to 1, we cannot fill anything here because this is the highest. There is no depth here. This is the highest point of the three, so we cannot fill anything here. And then 210, 210. For this one, we can fill 1 because, as you can see, we have the gap of 1 between these two. So we can fill 1 block here, and then for 0 we can fill 2 blocks here because the right hand side is 1, left hand side is 2. So first we'll fill this one area, then again water can overflow, but it can again go up because there is still open area which is blocked by other walls later, but we can fill it by 2, 1, and then so on. So how can we write a code that can do this or calculate these values? So if we look at every particular value and think about it, basically the amount of water we can fill always depend on the left and the right wall, but it might not be the immediate left. If you think consider this particular area, in this particular area, the immediate left is the leftmost wall of this bunch where this has the maximum height, whereas the right, if you look at the right side, this is taller than this, but this is not the tallest of the bunch. This is the tallest of the bunch. Why am I stating this is, let's say this wall, instead of having a height of 1, it would have been, let's say, 10. In that case, we didn't had to care about the leftmost wall. We could have just keep on filling it, and it would have filled up until the the highest point of the right side of the wall would have reached. So for example, this point. So in that particular case, the answer would have been 3 for this. So at every point, basically we need to consider the maximum left and maximum right side of the wall, and the amount of water which we can fill here will be the minimum of the maximum left side of the wall and maximum right side of the wall minus the current height. Okay, does that make sense? Okay, even if it doesn't, it will after we start coding it. So let's just do that. So we'll have a variable called maximum left, and let's just say this is 0 initially times length of height. Okay, and we'll have the same thing, and it will say maximum right. Okay, and what we'll do is we'll iterate through height first. So for um, value in height, and we need to keep track of a max. Okay, max will be max of max times value. So as we iterate through this, we'll keep track of the maximum value. Okay, and then we'll do max of left, because we are going from left to right, so we're going to update left value. And we also want to keep track of index. You enumerate. Okay, so max L of index will be equals to max. Okay, and we'll do the same thing, but this time we'll go from right to left. Okay, enumerate height. So let's, instead of doing this, how about we do for index in range length of height comma -1 comma -1, and then maximum is equals to maximum times height of index, right? And then max right of index is equals to max. Okay, so now if I print max left and max right, you'll see what I was talking about. What happened? So okay, we want to start from the last index. That's fine. So as you can see, if you look at this example, it's 0 1 1, then 2, and then 2 until we see 3, and then 3. So what does this mean? This is basically the tallest wall on the left side at every point. So you can see initially it was 0, then at this point the tallest wall is 1, and then at this point the tallest wall on the left side is 1 as well. So I guess what we can do is we can put this thing after. I think that will be better. Right? I guess it's fine. We only care about left and right, so it should be fine. Okay. Now, since we have this, what we want to do is we want to have a variable called result, or we don't need that. Let's say result is equals to 0. That's the area. Now what we'll do is we iterate through these height. Okay, we'll do for I in range length of height. So for and again I think this will be from, do we need to have the first? I don't think so. So we'll go from 1 to the second last, and that should be fine. Actually, I think we can just do this length of height. Okay, so the result will be added with the new height, which will be, so at every point what we want to do is we want to get maximum height of L at that index, right? And then maximum height of right at that index, right? And we want to get minimum of the both, and then subtract the current height. So height of I. Okay, So something like this, I think. uh, so this is basically doing what exactly we discussed. So we'll have yeah, okay, so let's just take this example one. If you see here, the maximum height of the left is 1, maximum height of the right at this point is 2. So sorry, maximum height of the left is 1 here, and maximum height to the right is 3. So if we start filling it, the maximum we can fill is till 1 because it will start overflowing. That's how we get the minimum, and we subtract the height. So let's say this one was 1, we wouldn't fill anything. That's why. Alright, so this should work. And yeah, so the time complexity of this is linear. As you can see, we just iterate through these things a bunch of times. That's it. Yeah, so let me know what do you think. Thank you.